Hello, welcome to this physics tutorial on forces and how it affects motion of objects. So this tutorial is about how resultant forces affect the how objects move, how they speed up, how they slow down, and what the relationship between them, and the use of mathematical formula. A for acceleration is related to F, the resultant force, and the mass of the object that the force is acting on. So this equation is given in the exam in the form of a formula sheet to you. You just have to be able to use this, rearrange this, and the equation is given in both forms, this as well as this. So all this tutorial prepares you is about how to use this formula and to be able to apply this in different situations. So here I've written down what these stand for. Again, this is given in the exam paper. Even the description for A is given as acceleration, F is resultant force, and M is the mass of the object. Bear in mind, A can stand for either acceleration or deceleration. So when object speeding up or reducing in speed or decreasing in speed, then we can use A. Or slow when the object slow down, again we have acceleration, but we use a different term as well, deceleration, but you can use the same formula for both. Now what you can see here is a resultant force. Now this means the force of the engine take away any friction on the wheels or the air resistance, all taken into account. That's the sum, or that's a resultant force. Okay, so we have that, and we also have the mass of the truck, 200 kilograms. Now as you can see, there is a load added to this, and the load itself is about 2500 kilograms. Okay, so now this truck is much more heavier, so this truck is heavier, so that's 6200 plus the load, obviously. Okay, let's consider this force is acting, that's a resultant force. What will be the acceleration of that? Now as you can see, this is more heavier, so if you rearrange this equation, so the mass of this truck is higher, so if you rearrange this equation, you have F equals m times A. You can also use a triangle if you're comfortable with a triangle, or if you're used to using a triangle more than just rearranging the equation, you have that. So the acceleration of this truck depends on the force and the mass. Now obviously the force is the same here in both cases, but the mass is higher here. So what's the effect of that? So if you hide the acceleration, A will be equal to F divided by M. So let me put F divided by M. This is the acceleration. So A equals this. Now when you increase M, because this is in the denominator, what happens to acceleration? It'll go lower. So whenever you increase the denominator, the acceleration, the value of that whole number becomes less. So the acceleration will be lower. Now it's so obvious, if you apply the same force on a heavier object, it will not accelerate as much as you push with the same force on a lighter object. Okay, let's actually put numbers in, substitute numbers in, and if you get the values that you would expect. 3500, so let me take another color. 3500 divided by the mass, which is 6200, you get an acceleration of, so for this truck which is not loaded, you get an acceleration of 0.56 meters per second square. As you remember, the unit for acceleration is meters per second square from part 1. Okay, so now you have the loaded truck, and you're applying the same formula. You have 3500, because the force is the same, divided by the mass. will be now 6,200 added to 2,500. As you can see, if we divide the force by the mass, you get 0.40 meters per second square. Compare that with that. Obviously, the lighter truck has accelerated. The acceleration of the lighter truck is higher than the acceleration of a heavier truck. Now this time it is 0.4 meters per second square. So that shows if you increase the mass, the acceleration will be less. And that's really intuitive common sense. And if you've been to shopping and if you push a empty trolley with the same force, it accelerates faster. Same as here. We've just looked at the effect of increasing mass, the acceleration decreased. But now if you increase the force again, if you just think about this without even using the formula, you push anything, any object that can move with a higher force, of course it's going to accelerate with a bigger acceleration. So the acceleration of this you can almost expect to be higher than this one because you're pushing this much harder with a bigger force. So let's actually substitute numbers here and check if this is okay, and if it is okay, what is the pattern, by how much this would increase in acceleration. The force divided by mass, that will give us the acceleration as before. Now the force is the same, 3,500. Okay, no, the force is not the same, 3,500. The mass in this case for the truck here, the mass is the same in both cases, so 6,200. So 6,200. So what is the acceleration in this case? Force divided by the mass, that gives you 0.56. Do the same calculation for this truck here with an increased force. So let's see what we get. Again, A equals, the force is 7,000 in this case, it's higher, divided by the same mass, same truck, same empty truck, 6,200 this time, and that gives us an acceleration value of 1.13 meters per second square. Now notice that this is twice as much as this one, so the acceleration has doubled. So, and it's obvious again, if you double the force, which is 7,000 is doubled, twice as much as 3,500. You double the force, you double the acceleration. So from 0.56 to 1.13. And in the previous case, what you have seen is when you double the mass, the acceleration becomes halved. To calculate the acceleration. Now, if you can see in the question, there are two forces given here. One is the forward force of the engine, which is the thrust, and we also have the air resistance. So the first task is to know what it is given. So F is given, so we need to work out the resultant force from these two forces. The mass of the motorbike is given, so mass is given, so obviously we have to work out the acceleration. So if you work out the resultant force, in this case 5,230 take away 730, so F would be 5,230 take away 730, and you should get, so you get 4,500 newtons as your resultant force. 4,500 newtons. Okay, so you have the force and you have the resultant force as well as you have the mass here. So A, if you rearrange this equation, F equals ma, as before, you can use the triangle. You get F divided by m. As I said earlier, it's useful to show you're working. F is 4,500 and the mass is 300. So that gives you 15 meters per second square. So that is the acceleration of this motorbike for the given resultant force. Oh. Formula F equals ma, m times a, mass times acceleration. But in this case, it's a different scenario where the diagram given is slightly complicated. A boat is pulling on a parasailer here with a force of F, and it clearly says in the question that this is a resultant force. Now, we have to find out the resultant force for this situation, okay? But the same formula, F equals ma, we can use. Okay, so F will be equal to, let's solve just that first part of the problem, and then we can go into explain, which is the second part of the question. Okay, so F would be now the mass of the parachute as well as the sailor, which is 120, times the acceleration given is 4 meters per second square. It's a straightforward calculation, but only the second part is slightly complicated. So if you just work this out, you get 480 newtons. So that's what we're going to put there, 480 newtons. Okay, right, now this is the resultant force that we've just worked out, 480 newtons. Now the pull force provided by the boat, as it's given here, the pull force of the boat should be greater than the resultant force. So here is a pull. Okay, and I'm going to draw a bigger arrow because this is the pull force of the boat on the person. Why this should be greater than the resultant force? And it is because if you go back to the resultant forces, it is the sum of all the forces that's acting. So that means the pull force should be greater than 480 because you have the air resistance to compensate. So you have some air resistance on the person, air resistance on the boat as well. So if you just combine these two together and say there is air resistance acting against the pull force, so the pull of the boat should be greater than the air resistance. That's what you should write as an explanation for this. So I'm going to write that here now. Force should be greater than 480 newtons as you have air resistance and drag against the direction of movement. Okay, so you not only have air resistance, you also have the drag of the water on the boat. So these two forces have to be overcome, and so the boat has to pull with a force much greater than 480 newtons. This example deals with a cyclist who's riding along a flat road here on this surface before he goes down this slope, slope B. Okay, now so he's already riding with a uniform speed, a constant speed, and he goes down the slope B. What can you expect to the speed of the cyclist? Now obviously he's going to accelerate and his speed is going to increase as he goes down slope B. So we're going to look at a graph. So in this example, the problem is presented to you in the form of a graph, and this is a scenario. So I'm going to move this away and put the graph. So this is going to be on the side here, so you can have a look at that. But we're going to mainly focus on the graph because that is what the question is going to use. So as you can see here, he's going in at a 3 meters per second, and that's his speed in this section. If you can see over here, 3 meters per second, uniform speed, and that's how he comes along this flat surface. Okay, so 3 meters per second, uniform speed up to 11 seconds, and when the time is 11 seconds, he starts to roll down here, and then he accelerates here. So our job is to find what the acceleration is, and when he reaches the bottom of the slope, now it's not very ideal. He should change the speed gently, but this graph shows abruptly changing, but that's okay. You can see now he is going at a slightly higher actually a good higher speed than where he came along the flat road here. So we're going to work out the acceleration. So would you be able to do that? And also we can work out the distance traveled along the slope, along the downward slope. Okay, so let's work out the acceleration first. You can see the time taken is from here, that is 32. If I go down that, it's 32 seconds to 12 seconds. So remember, notice that this goes up in twos: 12, 14, 16, 18, 20. So it goes up in two. So that's 32 and that's 12. Okay, so the time taken is 20. So t is 20. And then you have the distance covered. So the change in speed. So you need to work out the acceleration. If you remember from part 1, you need two things. One is the final speed, and then your initial speed u, and divided by the time taken, and this is acceleration. This formula is actually given in the exam, so you don't have to memorize this. And we also looked at a short form of this formula. Change in acceleration will be change in speed divided by the time taken. So whichever is comfortable for you, you can use that. Okay, so in this case, the change in speed is something that we need to work out. Okay, so you can see the final speed here is 27. So as you can see here, that's 27, and the starting speed is 3. So 27 take away 3 gives you 24. So the change in speed v is 27 and u is 3, so that gives you the change in speed of 24 meters per second. Okay, as you know, if you just apply the formula, so that's 20, a would be equal to 24 divided by the time taken, which is 20. Okay, so what does that give you? That gives you 1.2 meters per second square. Okay, so that's what that's the acceleration as it goes down the slope here. Okay, so that is the acceleration for this part. We can also work out the distance traveled here. If you remember from previous examples in part 1, you should be able to work out the area of this triangle and the area of the rectangle. I'm going to just quickly show that because we already covered that in part 1. So you can see here for the rectangle, the area would be 3 times 20. This time is 20 from here to here. So 3 times 20 is 60. So I'll put that 3 times 20 gives you 60 meters. So that's the area of this rectangle. And we know we're working out the distance by working out the area. That's why I'm putting the units for distance here. So that's 60. Looks like 80, but that's 60. Okay, 60 meters. So the total distance traveled is that plus that. That gives you 300 meters is the distance traveled. Okay, so this slope, the distance of this slope is 300 meters. Pretty huge slope. Okay, so that is how you use a graph to solve the solution with what you know. Okay, for this question, you can try to solve this yourself. Pause the video and check your answers when you have tried it. So I hope you've tried this and you can check if you got this right. You have the force acting on the bus. So F is given, as I said to you. It's useful to annotate the question, and you need to find the acceleration. Underline key parts of the question. A is something that you need to calculate. You have the mass information underneath, so look for this kind of information anywhere in the question. Sometimes the information is given near the diagram or somewhere along the question. Okay, so you have the formula F equals ma. You should be really using the formula sheet if you forgot it. Okay, so now you're actually calculating A. This acceleration should be equal to F divided by m if you rearrange this. So force here is given 25,500. Divide that by the mass of the bus 8,500, and that should give you the acceleration is 3 meters per second square. Then look at the second part of the question. What should happen to the engine force when passengers board the bus if you want to have the same acceleration? So the acceleration should stay the same. So that means if you use F equals ma, now you have actually increased the mass when the passengers board the bus. That means, as this is directly related to force, so if you increase the mass, the force must increase. The engine force should increase. And that is the answer for second part of the question. You should be glad to know that you have now reached the end of this tutorial. So well done if you understood everything so far. Try some practice questions later on, but first take a break. Well done.